In revealing the neurobiological basis of cognitive and psychological development in humans, neuroscientists mostly depend on close correspondence between structural, functional, and behavioral features during specific phases of development. Because the neural circuitry that underlies cognitive development is expected to be simpler in the developing than in the adult brain, the developmental approach should provide an easier analysis of principal elements of the neuronal circuitry: synapses, presynaptic axons, and postsynaptic neurons. It is difficult to correlate structure and function in the developing neuronal circuitry of the frontal lobe because of its complexity, lifelong maturation, and the existence of human-specific functions. Which component of the prefrontal cortical circuitry develops already in utero, that is, before birth? And knowing that typical prefrontal executive functions develop postnatally, what would be its functional roles during fetal life? In other words, what functions may the prefrontal cortex observe before the onset of cognition during the so-called precognition period of life? One would also like to pinpoint qualitative and quantitative features of the maturational status of prefrontal circuitry at the end of the first postnatal year. What level of maturation of prefrontal cortex is required for the onset of cognition and language? In this review, we summarize the data available on early development of human frontal lobe circuitry, describe new data on neurogenetic events obtained with neuroimaging and fine neurohistological studies, and propose structural criteria for delineation of phases in prefrontal circuitry development. We cover the period from the appearance of the cortical plate and establishment of first cortical synaptic contacts at 8th postconceptional week to the 3rd year of life, when pyramidal neurons of layer 3 attain size and complexity greater than those of layer 5 pyramidal neurons, and language and cognition are already well established. See Table 2.1. The following frontal cortical regions will be described: dorsolateral, dorsomedial, orbitomedial, precingulate, area 32, and anterocingulate, area 24.